Alright, so we have 8 elements. So there's only 2 elements left, the light and the dark.
Cartoons.
Today's episode, Crash Course Astronomy number 10, The Sun. Hello everyone, my name is Princess Celestia, and welcome to Toono This Weekend Reaction Time Let's Be Elements. And you know what? Tomorrow is gonna be a good day, the Skylanders 10th anniversary. Sun, what are you looking at? Me? I am the sun. Nice to meet you, Princess Celestia. Oh, nice to meet you too. So, here are some friends, like Vulpix, Nightlight, Spotlight, Astroblast, Sora, and Aurora.
Me? Sora means... Okay. Astroblast, you're not even a TV show. You're just a Skylanders. Me? I am Astroblast, not a show. Oh, too bad. So sad.
Today we are watching... Guess what I ever called? The Crash Course Astronomy number 10, The Sun. Here we go.
The sun is a star. That's a profound statement, and one that's not really all.
Ooh, I love the sun. Don't you, Vulpix? Vulpix! Vulpix!
Ooh, everybody knows about this one. Still got a unique stuff.
Are just different flavors of the same kind of object.
Still gotta organize. The sun is a planet!
Shut up, it's not a planet, it's a star.
Oh, right.
But that's not fair. Sure, it's somewhere in the middle of the size range of stars, but the vast majority of stars are dim red
What
dwarfs,
is a
far
diggity
smaller than the
do?
sun. By size and number, the
I
sun
think I
ranks
need
in
to
the
get a
top
project,
10% of stars in the galaxy. In our solar system,
Oh.
it's clearly the dominant
That's what I call it.
brighter, more
An
massive,
8-bit sun,
more
just like
influential than
me.
anything else. But what is it? The sun
No,
is
it's not
essentially
me,
a
it's-
big
this
hot
is
ball
different
of
sun.
mostly hydrogen gas.
Oh,
It's 1.4
okay.
million kilometers
The
across,
sun
more
is
than
not a
100
planet,
times the Earth's
but
diameter, and big enough that well
the sun
over
is like a
million
star.
Earths could fit inside of it.
That's
And it's massive,
enormous
300,000
sun,
times more
right?
massive than the Earth, a staggering 2 octillion
I'm sure it
tons
is.
of gas.
So stay tuned
To
because
truly
dark is coming up
understand the sun,
next.
we have to look
Ooh,
into its
really?
origin.
That's like in a stylish. We're going on the galaxies. We're one small step for the sun.
At the very core of the sun, conditions are hellish. The pressure is a crushing 260 billion times the
Vulpix?
atmospheric pressure.
I can't
and it's
see it.
15 million degrees Celsius. Under those conditions, hydrogen is completely ionized, which
Oh
means
my
the
goodness,
electrons in the atoms
that
are stripped
sun
from their
is
protons.
like
This
a-
makes the core a
like the
thick,
hottest
ultra-hot
planet.
subatomic particles. In fact, the protons are squeezed together so hard by the octillions of tons
Vulpix,
of mass lying
you're
on
not
top
even
of them
Pokemon
that the
language.
amazing thing happens.
Vulpix!
Fuse together.
Oh, there you go.
Complicated series of
Vulpix,
steps,
Vulpix.
hydrogen atoms fuse together to
Ooh,
form
I
the
really
heavier
love this
element
one.
helium. Along
Vulpix?
with this, the nuclear energy stored in
Thanks.
those atoms is
We had to
released.
speak
That
a
amount of
Pokemon
energy is
speak,
described
not
by
a human
Einstein's famous
language.
equation,
Vulpix!
States that mass can be converted into energy and vice versa. Atoms are pretty small though, so each helium atom made in the sun's core generates only a tiny bit of
Really?
energy, but a lot
That's
of helium
recognizing
atoms are
yourself.
made. A
Right.
lot. Get this. Every second of every day, the sun converts 700 million tons of hydrogen into
Wow,
695
that's like
million
heat.
tons of helium.
It's hot
Using 5
inside,
million
huh?
tons, the equivalent weight of 15
Oh,
Empire State
really?
Buildings is
Snap
converted
onto
into
my
energy.
fingers then.
That's a lot of energy. Enough, in fact, to power a star. It's equivalent to detonating 400 billion 1 megaton nuclear bombs every single second. That's millions of times the entire
Still got the
nuclear
lots
arsenal
of
our planet
sun.
every second. And that's why, even from a distance of 150
Ooh,
million kilometers,
sounds like
the sun
a
is so
solar
bright you can't
system.
even look at
Get it?
Even from that distance,
Now that's what I
it's
call
easy
it,
to
a
feel
solar
your skin when you
system.
stand outside. Hydrogen fusion occurs in the core
Thank
of the sun.
goodness.
The energy
That's
released
heat.
heats the gas
That's
above
heat of the
it.
sun.
Not quite enough to fuse
Still
hydrogen.
got quite enough it
Further
is.
from the sun's center, the gas becomes less dense, and at some point, the heat pouring up from below makes the gas buoyant. It rises in the same way a hot air balloon on Earth rises. This process is called convection, and it's an efficient way of transferring heat. Huge
I think you
columns of
need a big
rising
hurry
hot
about
gas
this
stretch
one.
hundreds of
But you
thousands of
still got a
kilometers high,
completion.
bringing the sun's internal heat to the surface. The gas then cools and sinks back down into the interior. We can actually see the
Vulpix.
tops of these columns packed together across the sun's face.
Come
Above
on,
the
it's just
convecting
billions
layer
of
is a much
stars in
thinner,
here.
cooler layer very near the sun's surface called the photosphere, or literally the
Ooh,
sphere of light.
I
This is
love
where
the sound of
density
that
material
bright
inside
stuff.
the sun gets
Still
thin
got
enough
the
that it becomes
lights.
transparent. Light can shine right through it. At this point, the energy from inside the sun is free to travel into space. It's this light that we see when we look at the sun. The sun is a gas and doesn't have a solid surface, but the gas in the photosphere
Ooh.
thins so rapidly compared to the sun's huge size that you can think of it as the sun's surface. And there's one final layer above that, the ethereally thin corona, sort of like the sun's atmosphere. It's less than 1% as dense as the photosphere, but actually
Ooh,
much hotter.
that's
Temperatures
a
there can reach
light.
over 1 million
Delightful.
However, it's so thinly dispersed that it's incredibly faint and can only be seen during a total eclipse or using special telescopes that block the intense light from the sun itself. The corona extends for millions of kilometers, and in a sense, it doesn't actually end. The corona
Hey,
emerges in
what
what's
do
called
you
a solar
know?
wind, a stream
It's
of
the
summoning
solar
particles away from
wind.
the sun. It blows out in all directions, though mostly along the sun's equator. The speed of the wind is usually well over 1,000,000 kilometers per hour. Yes, seriously. And can
Take
reach
that
speeds
heat.
even much
You
higher than
stow
that.
when you
When hydrogen
need,
fuses
right?
into helium in the sun's core, the energy is released in the form of
Just
light.
how
This light
long does it
immediately
take light to
smacks
reach
into a
the
subatomic
sun's
particle,
surface?
which absorbs it, converts a little bit of the energy into motion, and re-emits the light with a little bit less energy. The light works its way
Long
up the sun,
live the
losing
galaxies.
energy every time
We
it
come in
encounters the sun,
peace.
until
We
eventually it
are
gets to
the
surface and
Skylanders.
is free to fly away.
Hey, that's
As
what
much
I know.
energy
Mega said
as a place.
that.
How long does this
It was
process
absolutely
take?
right.
Some as much as
Me?
1,000,000 years.
Not
But
even
those
a single clip for
calculations
me.
don't model conditions inside
Oh
the sun
man, you
accurately.
can't
For
believe
example,
that.
they don't take into account the gas can
No.
hundreds of thousands of kilometers. More modern calculations show that it takes closer to 1 or 200,000 years for the energy to work its way out. That's still a pretty long time. The light you see from the sun now got its start in the sun's core around the time Homo sapiens first appeared in Africa. The sun's surface is,
I wonder
to put it
what the
kindly,
sun
a
shall
mess.
be.
And the key to that
Vulpix, Vulpix!
I've been saying the sun is made of gas, but that's not entirely accurate. It's so hot inside the sun that electrons are stripped from their parent atoms in the gas, creating what's called a plasma.
Oh,
Gaseous
plasma,
charged
huh?
particles. We'll learn more about that in a later episode. But what's important now is the fact that a moving electric charge generates a magnetic field. The interior of the sun is essentially all charged particles in motion. Convection, coupled with the sun's rotation, sets up rivers or streams of plasma inside the sun, each generating and carrying its own magnetic
Ooh,
field. When this plasma
unique.
reaches the sun's surface, their magnetic fields do too. Maybe you've seen those looping arcs of magnetism around a bar magnet when it affects iron filings on a piece of paper. The solar magnetic fields are like that, except there can be zillions of them all over
Hey,
the sun's surface,
you
where
got
they can
lots
interact
and lots
get
of
tangled up. When the
energy,
plasma
right,
reaches the
Aurora?
surface, it cools. But if
Yep.
the magnetic loops tangle up,
It's
they
still
prevent the
got
plasma from
delightful.
sinking back down into the sun. Like
Hey,
a
what do you
knot in a
know?
shoelace prevents it from
Still
going
got
through
the
eye line of
sun's
the ship.
heat.
Plasma shines because
It's not a flat, it's round.
It sits on the surface,
Seriously.
producing a
It's
dark
round
spot on the
surface, you
of
know.
the sun, which we call
A round surface.
sunspots can be huge. They come in
No!
the entire
Really?
Earth. Some
Sunspot.
are so big,
Is this
they can
just a
be
character
seen
from Ready,
without
Jet,
using a
Go?
telescope. As long as you're wearing adequate eye
Absolutely.
protection. Around the edges of
Absolutely
sunspots, the magnetic field lines are concentrated. This can energize the plasma even further, heating it up. This creates a bright rim around sunspots called faculae, Latin for little torch. The dark parts of sunspots dim the overall light from the sun, but faculae can be so intense they compensate for that and even add more light. Ironically, sunspots actually increase the energy output of the sun.
Ooh,
Plasma
that's
on
sort of
the
like
sun's surface can flow along
sunspots.
these magnetic
It's
loops,
really
too. This can
burned
create
up.
huge arcs of
Vulpix?
material called prominences.
You already got fire, so we are the light element. Remember?
We think these magnetic field lines are feeding energy from the sun's surface into the corona, which is why it's
Hey,
it's not
is there an
exactly clear how this
identity
happens,
book
but
of
scientists
this?
are following
Still
some
got
leads
it this
now.
one
This
too.
long-standing mystery may soon
I
be solved.
mean,
Magnetic
you
fields on the
get
sun
this,
also have
right?
a huge amount of energy stored in them. You can think of them like very
Really?
tightly wound and very stiff springs. But remember, these magnetic field lines get tangled up. If conditions are right, they can actually snap, in essence creating a gigantic short circuit. When this happens, all that vast energy stored in the lines explodes outwards.
Woo! That's really magic.
Even an average solar flare
Still a bit magic, huh?
exceedingly powerful.
Right,
Maybe it
guys?
can release as much as 10% of the entire sun energy output. This
Still-
explosion blasts
still
out
got
high
this.
energy light and launches material
This
off the surface
is
of
the sun
at high
from Blue
speeds,
Schools and You.
sending it into interplanetary
So I
space.
have
Another type of
sunglasses
solar
for a
eruption is called
star.
coronal mass ejection, or CME.
Vulpix?
It's similar to a flare, but if a flare is like a tornado, intense and localized, a CME is like a hurricane, huge and strong. Like flares, they form when tangled magnetic field lines erupt, blasting out energy, but they occur higher off the sun's surface. Both flares and CMEs
Oh,
inject material
what?
into space.
Am
Millions
I
of tons
supposed
of
to
it, in
be
fact. This
burned
blasted
up?
debris can hit the
Fire?
Earth, and when it does, there can be profound effects. Our atmosphere absorbs the high energy light, protecting us. Also, the subatomic particles are generally deflected by the Earth's magnetic field, so we're okay. But if conditions are right, the Earth's magnetic field can interact with the particles. Massive numbers are funneled down into Earth's
Whoa.
atmosphere near the poles.
Steve
causing
sat
the Earth
there
to
every
pulse.
day.
We call the Aurora, or the northern and southern lights. Depending on the shape of the magnetic field, the auroras can form
Hey,
spectacular
that's sort of
multicolored
like-
ribbons and sheets. Not
that's-
all the
that's
effects are
weird
benign, though. As the
looking.
magnetic fields interact,
Yep.
they can induce
Weird
very
looking
strong currents of
background.
electricity in the Earth's crust. This can
That's
overload
not
power
weird,
grids,
it's the
cause
sun.
blackouts. In
Remember, it's a
1989,
star.
that suffered a massive power outage from a solar storm. The very first such storm
Oh,
ever detected
poor
was in
thing.
1859.
Still
It
got
was
me
also
back.
the most powerful ever seen. If an event like
Vulpix?
that happened today, it could
You
cause
said it.
worldwide blackouts and potentially be very damaging. Satellite electronics would be fried too, and we depend on those satellites for our modern civilization. In fact, in 2012, a huge storm, probably the equal
Vulpix!
blasted away from the sun
Whoa!
in another direction, missing the Earth. Had it hit us, well, you probably wouldn't be watching this video now. We'd still be recovering. This is why studying the sun is so important. We depend on it for light
Sounds
and
like a
heat
bit
and the very
tricky.
basis of life itself, but it's entirely capable of knocking our society to its knees. Understanding it is critical to our future. The sun is the 2 octillion ton. We
Ooh.
need to respect that. Today you learned that the sun is a star powered by nuclear fusion in its core. Hot plasma moves inside the sun, creating magnetic fields, which in turn can create sunspots, solar flares, and coronal mass ejections. These events can generate aurorae on Earth, cause power blackouts, and damage satellites. This episode is brought to you by Squarespace, the latest.
Well, that's about it. So, there's only one more element go, and you'll complete this reaction time for Let's Be Elements. So, the 10th anniversary of Skylanders is coming tomorrow, and we'll find out next time, alright? See you next time!